Okay, so in this video, we're going to work this example of an initial value problem with an eye towards redoing it as a differential equation, and you'll get from that comparison. Hopefully, you'll get what it means to have a differential equation. So this is something that we've really done before. I guess this was the very end of what would that be? Module 7, I think. I'm not quite sure now that I think about it, but. So this is an earlier module or earlier chapter, and where we dealt with this. And basically, when you're given a derivative function and what's called an initial value, f of 0 was 4, right? Here's the derivative, and here is some value of it. Well, we can work backwards through an antiderivative to find the original function. So f of x is going to be the antiderivative of f prime of x, 2x minus 1. When you find an antiderivative, or an indefinite integral, we're going to use the power rule. So the antiderivative, or rather an antiderivative of 2x will be x squared. This one is chosen to be relatively simple. And an antiderivative of 1 would just be x, so minus x. And then you always put plus c at the end of your antiderivative, because it's kind of like there's a sneaky plus 0 hiding out at the end of the function, because when you find the derivative of a number, you get 0. So maybe there was a number there all along. Maybe it was 7 or 8 or 12. We don't know. But this is called an initial value problem because we're given when you input 0 into the original function, you should get 4 as a result. So that means that since this is my function, f of x equals x squared minus x plus c, if I plug in 0 here, f of 0 would be 4, right? And then we'll say, okay, well, x is 0, so this is 0, this is plus c. So that means that c, the number c, should be 4. And we can think of it if we want as, oh, it was 4 all along, but we don't know that. This c is 4, but we don't know that until we plug numbers in and check. So that means that my real solution is f of x equals x squared minus x plus 4. Okay, so this is the way we solve the initial value problem version of this example. One thing that will lead into the next example is that this solution is often called the general solution. This is also why this is called the general antiderivative. This is the general solution to the initial value problem. Make sure I write that a little bit more neatly. Once we find out what C is, this is called a particular solution. I guess you could call it also specific solution, but the term particular is what's used, particular solution. So there you go. That is something we've already done, but it's just a rehash of how do you solve this problem with an initial value approach.